Welcome to techdaily.ai. Get ready for another deep dive where we really try to cut through the noise and bring you the most essential insights. Today, we're unpacking a concept that's, well, it's quietly but profoundly reshaping how we interact with technology and data every single day. But first, just a quick word from our sponsor.
This deep dive is brought to you by Stonefly. They're your trusted solution provider and advisor in, well, pretty much everything: storage and infrastructure enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox clusters, AI servers, SA365, which is a turnkey security appliance, and public and private cloud solutions too. For more information on how Stonefly can support your infrastructure, definitely check out stonefly.com. Okay, so let's unpack this. Our world is, it feels like we're literally drowning in data, doesn't it?
It really does. The numbers are just astronomical.
We're talking trillions of gigabytes being generated, like, constantly by devices, networks, everywhere.
And it's only accelerating. Forbes estimates that by 2025, we'll be dealing with something like 150 zettabytes. I can barely wrap my head around that number.
It's almost unimaginable, yeah.
And here's the kicker, right? Over half of that data is expected to come from what we call the edge of the network.
Exactly, right, where the data is actually created, far from the traditional data centers.
So this explosion of raw data and this urgent need to process it quickly has led to a really fascinating shift in computing.
What's fascinating is precisely that shift, like you said.
Yep.
Historically, the default was always send everything back. Send it all to a centralized cloud for processing, for analysis.
Right, the big brain in the sky model.
Pretty much. But that traditional approach is really starting to creak under the pressure now, especially for applications that demand immediate, like, split-second action. That inherent latency, the time delay sending data all the way to a distant cloud and then waiting for a response. Well, it can make insights stale or even dangerous in time-critical situations.
Yeah, milliseconds matter in some cases.
They absolutely do. So it's not just a technical challenge anymore, it's become a strategic one. How do we manage this data deluge efficiently, effectively, especially when every millisecond counts, when we need instant decisions right there on the ground?
And that's exactly what we're diving into today. Edge computing. We're going to explore what it is, why it's becoming so critical, its core benefits, the challenges it definitely presents, and some incredible real-world applications that are already transforming industries. So let's start with the basics then. At its heart, what exactly is edge computing?
At its core, edge computing is a distributed computing model. Fundamentally, it brings the computation and the data storage closer to the very sources of the data. So instead of sending everything miles away to a centralized data center, think of it as moving the processing power, the brain if you like, right to where the data is actually created.
Okay.
That could be a sensor, a camera, an industrial robot, even your smartphone sometimes. It's all about decentralizing those computing resources.
So that proximity, it's not just about making things faster, is it? It seems more fundamental.
It is. It's about rethinking how we handle the sheer volume and the immediacy of data today.
But, this idea isn't entirely new, right? We've had distributed systems before, content delivery networks, things like that. What makes edge different now? Why the big push?
That's a great point. You're absolutely right. The concept isn't brand new. Like you said, CDNs in the 90s were placing web and video servers closer to users. That was a form of edge. But what's dramatically changed is the sheer, overwhelming volume of data pouring in from billions of connected IoT devices, the Internet of Things.
Right, everything's connected now.
Exactly. And combined with that is the escalating demand for real-time, instantaneous responses from those devices. We've sort of shifted from just optimizing content delivery to optimizing actual decision-making at the source.
Okay, that makes sense. So here's where it gets really interesting for me. If the traditional cloud model is, as you said, creaking under this pressure, what are the main driving forces pushing organizations to adopt this edge concept right now? What are the big motivators?
Yeah, there are 4 primary motivators, and they're really crucial to understand because they each address a critical pain point. First up is latency reduction. This is huge.
Right.
So many modern applications, you think about Industry 4.0, autonomous driving safety systems, real-time patient monitoring in hospitals, immersive AR, VR, they all demand deterministic, ultra-low latency, like predictable, fast responses.
Right, waiting is not an option.
Exactly. Waiting for data to travel to a central cloud and back just introduces delays, and those delays can lead to safety issues, missed business opportunities, or just a terrible user experience. Edge computing lets decisions be made locally, in milliseconds.
Gotcha. Okay. Latency is number one. What's next?
Secondly, privacy and security. This is increasingly important.
Oh, yeah, definitely.
Think about transporting vast amounts of potentially sensitive user data, like your detailed energy usage from a smart meter or precise vehicle movements from a connected car. Sending all that to a central cloud, that raises huge regulatory and privacy flags.
And different regions have different roles.
Precisely. Local regulations vary wildly. Edge computing can act as a vital intermediary here. It could provide a crucial layer of anonymity by maybe aggregating data, processing it locally, and then perhaps only sending anonymized insights or summaries upstream to the cloud.
Ah, so it acts like a filter or a guardian?
Kind of, yeah. It enhances privacy and really helps organizations comply with diverse local rules, like HIPAA in healthcare, for example.
Okay, latency, privacy. What's number 3?
Thirdly, there's data volume and backhaul bandwidth optimization.
Mm.
This is a very practical concern. Just the massive continuous data streams coming from countless IoT devices can easily overwhelm your network infrastructure. Think about the backhaul networks connecting everything.
Right, the pipes get clogged.
Exactly. And that creates congestion. Plus, it incurs huge data transport costs. Edge nodes can be programmed to intelligently aggregate, filter, and maybe pre-process this raw data right there. So you end up sending only the critical information or maybe just concise summaries to the central servers. This significantly conserves precious bandwidth, reduces network congestion, and ultimately lowers your operational costs. It's about being smart with the data you move.
Makes sense. Don't send everything if you don't need to. And the 4th.
And finally, a key driver is the need for autonomy.
Meaning?
Meaning the ability for systems to operate independently even if they lose connection to the central cloud. Many applications, particularly in sectors like Industry 4.0 or smart cities, they need local context-aware processing. They need to make decisions based on what's happening right there, right now. Sometimes this is to comply with specific local policies or regulations, or sometimes it's simply because the system must continue functioning even if this connection is temporarily lost. Edge computing enables this independence.
So the factory floor keeps running even if the internet connection blips out.
That's the idea. It ensures local systems can operate and make decisions even in isolation, adapting to immediate local conditions.
So, wow, it's clearly not just about speed anymore, though that's obviously a huge factor. It's this mix of control, cost savings, smarter data handling, keeping sensitive stuff local and secure. It really paints a compelling picture.
It does.
But, I mean, with all these decentralized points, doesn't that make managing everything way more complex? Doesn't it potentially, I don't know, increase the attack surface for security threats?
That's a very perceptive question, and yes, absolutely, it does introduce new layers of complexity. Managing distributed systems is inherently harder than managing a centralized one. And yes, security needs careful consideration at every edge point, but the benefits, when architected correctly, often outweigh those challenges. And beyond those core motivations we just discussed, the tangible advantages are really compelling.
Okay, like what? Let's dig into the benefits.
Well, we mentioned ultra-low latency. That's not just a buzzword, right? It's absolutely paramount for things like autonomous robots on a factory floor or predictive maintenance systems that use, say, tiny ML to spot anomalies and vibrations just before a machine fails.
Preventing disaster, basically.
Exactly. Edge processing bypasses those long round trips to the cloud, making instantaneous reactions truly possible. Then there's operational resilience. We touched on this with autonomy. If your main cloud connection drops, edge devices can often keep operating independently.
Business continuity.
Absolutely. Huge for business continuity. Imagine that factory floor again. It doesn't grind to a halt just because of a temporary internet hiccup.
It's a big deal. What else?
Well, improved efficiency and lower cloud costs. This is often underestimated. By processing and filtering data locally, right at the edge, you drastically cut the volume of raw data you need to ship to the cloud, store in the cloud, and process in the cloud.
Right. Less data transfer, less storage.
Less network congestion, faster overall processing because you're dealing with less junk, and significantly lower bills for cloud storage, compute power, and bandwidth. You're sending the valuable, often pre-processed insights, not the raw fire hose. That can be a huge cost saving.
Yeah, I can see that adding up quickly.
And then there's scalability. Edge systems offer a different kind of scalability. You can deploy edge hardware, which is often lower cost per unit than massive servers in all sorts of diverse environments. You can scale your operations modularly, adding intelligence where you need it without necessarily overloading your central infrastructure. It's a more distributed, flexible way to grow.
More adaptable, maybe.
Yeah, adaptable is a good word. And finally, back to security and privacy. Stronger data privacy and security. Keeping sensitive data on premises or within controlled local networks inherently minimizes its exposure. Less chance of interception during transit over public networks. Plus, it really helps adhere to strict regulations like iPay for healthcare data
Mhm.
because you can process that sensitive info locally, keeping it exactly where it needs to be under tighter control.
Okay, those benefits are clear and pretty significant. But you did mention the complexity. This really sounds like a huge undertaking. It requires careful planning, sophisticated infrastructure to manage all these, distributed points. How is this actually built? How is it standardized so all these different devices and locations can work together?
That's the million-dollar question, isn't it? How do you make all these diverse systems play nicely together?
Mhm.
Edge computing does involve this broad continuum, like you said, from tiny individual devices right up to large regional data centers acting as edge hubs. To manage this complexity, several global standards bodies are actively working on defining architectures and protocols.
Right, so what are the key pieces?
At its core, a typical edge system has three main components. You've got the edge devices themselves, the sensors, cameras, machines actually generating the data. Then you have edge nodes or gateways. These are intermediate devices. They have local computing power, and they collect, filter, maybe aggregate, and process the data from the nearby devices.
Kind of like local mini data centers.
In a way, yes. Sometimes quite many, sometimes more substantial. And finally, you need orchestration and management platforms. This is the crucial software layer. It's designed to manage these distributed data flows, deploy applications out to the edge devices remotely, monitor their health, update them, manage the whole fleet, basically.
Okay, and who's setting the standards for all this?
Several key groups are involved. You have organizations like 3GPP, they're huge in the 5G world, defining how edge fits into mobile networks. Then there's ETSI, the European Telecommunications Standards Institute. They're well known for their work on MEC, or multi-access edge computing, which focuses on bringing cloud capabilities right to the edge of the mobile network, closer to users. And you also have the IETF, the Internet Engineering Task Force, looking at standards for what they call BEC, or Beyond Edge Computing, pushing compute even further out. The goal of all these efforts is to enable flexible placement of compute and storage across the network and ensure things can actually interoperate.
So there's this idea of a continuum.
Exactly, the edge computing continuum. Think of it as a spectrum. It helps visualize the trade-offs between latency needs and processing power needs. On one end, you have cloudification, where you push tasks that are latency tolerant, maybe bulk data processing deeper into the network or towards the central cloud. On the other end, you have edgification, where you move real-time, ultra-low latency applications much, much closer to the actual data source.
So for businesses, it means choosing the right spot on that spectrum for each specific application.
Precisely. You need to decide where an application should live based on its specific needs for responsiveness, for autonomy, for location awareness.
But managing all that, you mentioned orchestration challenges.
Yes, and they are significant. Managing these distributed resources at scale is tough. You're dealing with resource constraints, power, CPU, storage, especially on smaller devices. You're dealing with potentially huge numbers of devices to manage. And you need that autonomy. We talked about what happens if the connection drops. How do the management tools handle that? Existing orchestration tools, which were largely built for big, homogeneous cloud data centers, are having to evolve rapidly. They need to adapt to manage this, well, more diverse and geographically scattered environment. It's almost like learning to manage a sprawling wild forest instead of a single, perfectly manicured garden.
That's a really good analogy. It definitely highlights that this isn't just theory anymore. Edge computing is really out there, making a difference, often behind the scenes. What are some of the most compelling, maybe even surprising, real-world examples you're seeing today? Where is Edge making a tangible impact?
Oh, the impact is incredibly broad now because it brings that intelligence and decision-making right where it's needed most. Let's look at a few transformational examples. Take autonomous vehicles. Self-driving cars rely massively on edge computing. They have to instantly interpret continuous streams of data, LiDAR, radar, cameras, and make critical navigation and safety decisions in milliseconds. There's no time to ask the cloud. Right. Or imagine platooning truck convoys on the highway. Only the lead truck has a human driver. The rest follow in tight formation, connected by edge-powered vehicle-to-vehicle communication. They're reacting to each other and the road instantaneously. That's edge in action. Wow. Okay, what about healthcare? In healthcare, especially inside hospitals, edge computing ensures critical patient data is processed locally. maybe analyzing monitor readings right at the bedside and routing alerts instantly to doctors or nurses for real-time analysis. This is absolutely vital for things like robot-assisted surgery, where lag is unthinkable. And it's crucial for complying with patient privacy laws like IPEA by keeping that sensitive data within the hospital's secure network perimeter.
Makes sense. And manufacturing.
Manufacturing is a huge area. Factories are deploying edge systems everywhere for asset monitoring, predicting machine failures before they happen, often using that tiny ML we mentioned, running AI right on the sensor to spot anomalies early. For quality control on the production line, this leads to way less downtime, lower operational costs. Even smart farming is using edge. Think private wireless networks in rural areas, connecting sensors in fields, using edge processing to analyze soil conditions or weather in real time to optimize irrigation or fertilization, boosting crop yields.
So bringing intelligence to places that might not have great connectivity otherwise.
Exactly. What about retail? Edge is changing the customer experience there too. Things like facial recognition for faster, maybe even walkout checkouts. Object recognition cameras for automated inventory management, knowing instantly when a shelf is empty. And delivering personalized product recommendations or offers to your phone in real time as you walk down an aisle. Hyper-personalization at the point of interaction.
Creepy, but potentially useful. Security must be a big one too.
Security, absolutely. By processing data locally, edge computing strengthens cybersecurity in a few ways. It can stop malware closer to the front gate of the network, right at the edge device, preventing it from spreading deeper into your systems. It also enhances fraud detection for banks, for instance, by analyzing transaction patterns closer to the point of sale for faster flagging of suspicious activity. And for high-security environments like government facilities or research labs, processing sensitive data locally keeps it away from potential exposure on public networks or clouds.
Right, keeping the crown jewels locked down.
Precisely. And even sustainability is benefiting. Edge computing helps monitor protected wildlife in remote national parks, using AI-powered cameras to identify animals or detect poaching activity and instantly alert rangers. It supports smart grids for more efficient energy distribution, reducing waste. It enables remote monitoring of oil and gas pipelines or wind turbines in rugged, hard-to-reach locations, improving safety and maintenance efficiency.
That's fascinating, using it for conservation.
Yeah. And finally, think about urban design and smart cities. Cities are using edge devices for predictive maintenance on bridges or buildings, analyzing sensor data for stress, for managing fleets of city buses or emergency vehicles based on real-time traffic conditions, for analyzing traffic patterns using cameras at intersections to dynamically adjust signal timings and relieve congestion. All rely on instant, local data processing.
That's an incredible range. It's really diverse. It just highlights how embedded this technology is becoming, often, like you said, without us even realizing that complex computing is happening right there. So it sounds like edge computing tackles a lot of the challenges we associate with the traditional centralized cloud model, which leads to the big question. Is the edge going to replace the cloud? Are we heading towards a future without massive data centers?
If we look at the bigger picture, it's definitively not about replacement. It's really about a powerful synergy. While edge and cloud can sometimes seem like opposites, they're actually incredibly complementary. They each excel at different things.
Okay, so they work together.
Absolutely. The cloud's strengths remain vital. The cloud is still essential for large-scale deep data analytics over historical datasets, for handling truly massive data volumes, for archival or batch processing, and for applications where latency isn't the primary concern. The cloud offers that immense, almost limitless scalability and efficient resource pooling that edge systems, by their nature, can't match on their own.
Right, the big picture analysis still needs the cloud.
Often, yes. Conversely, the edge's strengths are precisely where it shines. Real-time performance, localized autonomy, bandwidth optimization, immediate response. It's the go-to for instant decisions, local data filtering, ensuring things keep working even if the network is spotty.
So the best approach is a mix.
Exactly. The most effective solution for most organizations, and probably for you listening, is usually a hybrid or multi-cloud environment, one that intelligently integrates both edge and cloud capabilities. This means you process the time-sensitive, immediate data right at the edge where speed and local context matter most. Then you strategically send only the relevant, perhaps pre-processed, maybe anonymized or encrypted data up to the cloud.
For what purpose?
For deeper, longer-term analytics, for consolidating data from many edge sites, for long-term storage, or for applications that benefit from the cloud scale. This integrated approach lets you optimize everything: cost, performance, security, compliance, by using the best tool for each part of the job.
So it's not an either situation at all. It's about finding the right balance, leveraging the best of both worlds, matching the computing environment to the specific needs of each task. That makes a lot of sense.
Mhm.
So, given this rapid evolution, this widespread adoption, what does the future hold for edge computing? Where do things go from here?
That's a great question. How will this paradigm continue to evolve?
Yeah.
One major trend we're seeing is a significant shift towards serverless edge computing.
Serverless at the edge. How does that work?
It means developers can focus just on writing the code, the function they want to run at the edge, without worrying about provisioning or managing the underlying server infrastructure or resources on those edge devices. The platform handles that automatically.
Makes it easier to deploy code out there.
Much easier. And this serverless at the edge model is going to be crucial for enabling even deeper integration of several key technologies that really power the next wave. Firstly, that convergence of IoT, AI, and 5G. We talked about it, but it's a true game changer. You combine 5G's low latency and high bandwidth with powerful AI processing happening right there at the edge.
And you unlock new possibilities.
Totally new categories of applications. Think truly advanced autonomous systems, not just cars, but maybe swarms of drones, sophisticated robotics in complex environments, real-time computer vision doing complex analysis on the fly, things that were just impossible before due to network limits or lack of local processing power. This synergy unlocks incredible responsiveness and intelligence.
Okay, what else?
Secondly, edge computing is really a foundational pillar for this ambitious vision called Society 5.0. Have you heard of this?
Vaguely, yeah. It's a concept out of Japan, right?
That's right. It describes this idea of a super smart society where the digital world, cyberspace, and the physical world are seamlessly blended, where technology is deeply integrated to enhance human well-being and solve societal problems. Society 5.0 relies heavily on edge computing to connect everything, infrastructure, homes, businesses, individuals, and to enable those real-time data-driven decisions can improve economic development, address challenges like aging populations or environmental issues. It's about embedding intelligence everywhere in the physical world.
So the potential is truly immense. It sounds like a much more connected, responsive, maybe even intelligent world. But as you've pointed out, getting there requires constant innovation, solid development practices, and ongoing standardization to make sure all these pieces can actually work together reliably.
Absolutely. The technical and organizational challenges are still significant.
Well, this deep dive into edge computing has certainly shown us that data isn't just the new oil, as they say, but it's this rapidly expanding, incredibly dynamic resource that needs really sophisticated, intelligent management, often right where it's being generated. Edge computing is stepping up. It's providing faster insights, crucial autonomy for local operations, enhanced security, placing these capabilities right where you need them most, out there on the front lines. The challenge now, as you've highlighted, seems to be integrating all these diverse pieces, the specific applications, the different types of edge devices, the various service providers, the complex software stacks, integrating them holistically to really unlock the full potential, creating that unified ecosystem. That's the key: integration and orchestration at scale.
So the final thought, maybe, for you, our listener, is how will you leverage this distributed intelligence? How can edge computing drive your next big idea or help solve your next critical challenge? That's all the time we have for this deep dive into edge computing. Thank you so much for joining us on TechDaily.ai.
Thanks for having me.
And before you go, just one more reminder about Stonefly's incredible offering: a 100 TB immutable and air-gapped SSO NAS for just $8,995. That's an excellent way to secure your critical data, whether it's at the edge or right in your data center. It provides really strong protection against things like ransomware and data loss. You can find out more at stonefly.com. We'll see you next time for another deep dive.